Section 2.2, multiplication with variables. Okay, so in the last section we added and subtracted terms, right? Terms which were these items that had numbers and variables merged together with multiplication. Okay, so we're going to keep on working with that terminology and we're going to add on to it as we discuss multiplication with variables. Okay, so the first thing that I want to talk about is this idea of a factor. Okay, factors are expressions that are multiplied together. Okay, that's a simple way to put it. So 9x to the fourth and 2x would be factors of 9x to the fourth times 2x, right? That expression there has factors, 9x to the fourth and 2x. Same is true for negative 2t cubed times negative 8t to the fourth. There are negative 2t cubed and negative 8t to the fourth. Those are the factors, okay? Or at least some of the factors. And expressions like this, 3 times 5x minus 2, 3 and 5x minus 2 are factors. Okay, so factors, things that are held together by multiplication. Okay, so let's talk about some of these and how to work them out, how to simplify them. Okay, so this 9x to the fourth times 2x. Let's think about what's going on here. 9x to the fourth, that exponent to the fourth power, means that I have 4 x's being multiplied there, right? So we have 9 times x times x times x times x, right? That's 9x to the fourth. And that's being multiplied times 2x, which is, of course, 2 times x. Okay, so let's kind of rearrange it a little bit, right? Multiplication, the order doesn't matter, right? It's commutative. So we could write this as 9 times 2 times x times x times x times x times x, right? That's 4 x's from here and an x from there. Put those together, we have 5 x's. So if I actually multiply this together, the 9 times 2 here is 18, and this x times itself 5 times would be x to the fifth power. So 9x to the fourth times 2x is 18x to the fifth power. Okay, what about negative 2t to the third power times negative 8t to the fourth power? Okay, well, let's do this again. We have negative 2 times t times t times t, right? That's the t to the third power there. And then we have this times negative 8 times t. We got 4 t's here. Okay, so let's shuffle it around a little bit. Negative 2 times negative 8, I can multiply those together. And then we have all these t's. We got 3 t's from the first factor, and we have 4 t's from the second factor. Okay, and so negative 2 times negative 8 is 16, positive 16, right? And then we have 7 t's being multiplied together, so they were going to have our seventh power. 16t to the seventh power. Okay, that is not the most efficient way to do that, right? Obviously. So we're going to talk about some of the laws of exponents. So here's the first one that we're coming across right now. Whenever you are multiplying factors together, okay, and you have the same variable, but with exponents that may be different, they may be the same, you can consolidate them. You can write it as one variable with a single exponent. You just add those exponents together. Okay, that's what this is saying right here in a little bit more abstract way. Okay, so what does that look like? Let's go back to these two examples here. 9x to the fourth times 2x. First of all, I'm going to acknowledge the fact that if I don't have an exponent written, it's understood to be a 1. Okay, that just means you have 1x being multiplied. So the 1, you don't need to put it, but it's there. And so if I'm trying to multiply 9x to the fourth times 2x to the first, keeping in mind I can shuffle things around, 9 times 2 is 18, and x to the fourth times x to the first, we'll add those two numbers together. 4 plus 1 is going to be 5, so we have 18x to the fifth power. That's a lot easier to do than to write it all out like we did a second ago. Okay, and again, you can skip writing this step out altogether. You don't need to write out the 4 plus 1 to know that it's 5. Okay, let's do the same thing with this one here. Negative t cubed minus 8t to the fourth. Again, you can shuffle things around. So negative 2 times negative 8 is going to be 16, and then we have 3 t's here and 4 t's there. Put that together, we are multiplying 7 t's. So we have 16 t to the 7th power. Okay, so the law of exponent, where we add the exponents together, that's going to make these problems a lot easier. Okay, so let's keep going. What about this 3x to the 5th minus 2? Okay, this one, there's a couple of ways we're going to approach it, but let's start off at face value, what it says. It is saying 3 times 5x minus 2. In other words, you have 5x minus 2 3 times, okay, all being added together, right? So 5x minus 2 plus 5x minus 2 plus 5x minus 2. Notice what's happening here. We are writing these terms, right, this expression 5x minus 2 3 times and adding them together. That's what multiplication times 3 means, right? Now, in the last section, we talked about combining like terms. In this case, we have 5x plus 5x plus 5x. 5 plus 5 is 10, plus 5 is 15. So we have 15 x's there. And then we have this negative 2 minus 2 minus 2. Negative 2 minus 2 is negative 4, minus 2 again is going to be negative 6. So we have 15x minus 6. But that's not the easiest way to do this type of a problem. Okay, I mean it works, but they do get more complicated, and we don't want to have to write 5x minus 2 over and over again. What if this, instead of a 3, was a 300, right? You don't want to do that. So what are we going to do? We're going to talk about the distributive property. Okay, so the distributive property takes an expression that's written as factors and rewrites it as terms. Now, I know exactly what I'm looking at here. This is definitely 2 factors, right? And here we have 2 terms within it, right? That's why I say it's primarily written as factors, as in if I look at this, if I look at this, get back right here, this right here is mostly multiplication happening, right? There's definitely addition happening inside, but it's a multiplication type problem, primarily. Here, this is an addition problem. Now again, it does have multiplication going on, right? There's a times b and there's a times c. Okay, so just being careful with our terminology here. I know that these both have factors and they both have terms, but this one is primarily factors, this one is primarily terms. Okay, anyway, with that little distinction in mind, notice what's happening here. A times b and a times c. You're distributing that number, right, whatever a represents, that number or variable, you're distributing it. You're bringing it to each of the 2 terms and multiplying them separately. Okay, so let's see that play out without having to do this the long way, right? So we're going to say, all right, 3 times 5x. So keep in mind what's happening there. 3 times 5x just means 3 times 5, which is 15. X's, right? Remember, we had 5x plus 5x plus 5x. That's just 3 times 5x, right? Same thing is going to be true here. 3 times negative 2. 3 times negative 2 is negative 6. So we distributed the 3 by multiplying it to each of the terms, and now we rewrote this expression that was once written as factors primarily and now is written primarily as terms. Okay, this is a more complicated version of the same problem. Let's multiply that out. So negative 3x to the 3rd power times 5x to the 4th power. Let's keep in mind, when we're multiplying these types of terms together, we do the negative 3 times 5. That's negative 15. And then we have x to the, add them together, 3 plus 4 is 7. So this is negative 15 x to the 7th power. Now let's distribute this negative 3x to the 3rd power times this negative 2. Well, negative 3 times negative 2 is a positive 6. Okay, now what about the x's? Well, we had 3 x's here. We have no other x's here, but we still are bringing these 3 x's across when we multiply it. So this is still going to be 6x to the 3rd power. So there we go, negative 15x to the 7th power plus 6x to the 3rd power. Now we can get more complicated as we go. Look at these right here. X plus 3 times x squared plus 1. Alright, so we're going to work this out, I guess, 2 different ways. Okay, the first way is we're going to distribute this entire x plus 3, x plus 3 times x squared. Well, we're going to just write that as x squared times x plus 3. And then we're going to take that x plus 3 and multiply it times 1. That's going to give me 1 times x plus 3. Okay, so here we have now two terms that are definitely multiplication problems, right? And the distributive property will apply there as well. So what are we going to do about that? Okay, well, what we can do is distribute the x squared. Okay, so x squared times x is going to be x to the third power, right? Because it's an understood 1. 2 plus 1 is 3, so x to the third power. X squared times 3, well, that's going to just be 3x squared, right? This 3 had no x's to contribute, but these two x's still were brought over. Okay, now we're going to distribute this 1. 1 times x is 1x. You don't usually put the 1 in front because you know you have 1x if you write it. And then 1 times 3, that's the easiest question we've had so far. That's just 3. So we have x to the third power plus 3x squared plus x plus 3. None of these are like terms, so I can't put them together. Okay? Right? Remember, they're like terms if they have the same variable structure. That's x to the third power, x to the second power, x to the first power, and no x, right? A constant term. None of these terms are alike. Okay, so that's one way we could approach this problem. An easier way to approach this problem is to recognize that you're going to have to distribute the first term and you're going to have to distribute the second term. So I could do it like that, right? Where I actually just do it all at once. So if I tried it that way, z times z, keep in mind there's first power and first power, you add those together, you get z to the second power, and z times 5 would be a positive 5z to the first power, of course. And then I'm going to take this 3. 3 times z will be 3z to the first power, and 3 times 5 would be 15. Okay, so now I'm going to check for like terms. I look at z squared. I don't see any other z squareds, so I will just bring that down. I have a positive 5z and a positive 3z. Those are like terms, right? Those are z to the first power. Okay, in the last section we talked about it. 5 plus 3 is 8, so this is 8z. Notice I'm not putting their exponents together, right? I'm not multiplying the exponents or adding the exponents or anything like that. When you combine like terms, the exponents stay the same. That's what we emphasized in the last section. In this section, when you multiply two variables together, then you're going to add their exponents. Okay. All right, then bring down the 15 because we don't have any other constant terms. So z squared plus 8z plus 15. Okay. Let's keep going. So I don't want to do these the long way, right? So what I'm going to do here is just multiply, distribute the negative 5x. Negative 5x times x squared is going to be negative 5x to the third power, right? Again, understood 1, so I add 1 plus 2 and get 3. Negative 5x times negative 4x would be a positive 20x to the second power, right? Because they both have a 1, so add those ones together and you get 2. Negative 5x times negative 3 would be a positive 15x. Okay, so I have distributed this negative 5x across. Okay, now I'm going to take this 3 and distribute it. 3 times x squared is a positive 3x squared. 3 times negative 4x is negative 12x. And 3 times negative 3 is negative 9. Okay, so I've distributed each term in the first set of parentheses to all three terms in the second set of parentheses. Now I'm going to combine like terms if I have them. I only have one term that has x cubed, so I'm going to bring down 5x cubed. I have 1, 2, two terms that have x squared, so I'm going to combine 20x squared plus 3x squared to get 23x squared. And I have 15x and negative 12x. Those are like terms. 15 minus 12 is 3, positive 3. So we have positive 3x there. And then I have this constant term, negative 9. It's the only constant term, so that's the only one that gets written down here. Okay, what about something like 2x minus 3 raised to the second power? Again, remember what that exponent 2 means. It means that whatever is being raised to that power is multiplied times itself, right? At least multiplied twice, right? So 2x minus 3, 2x minus 3. We have two factors of the same thing. So we're going to, again, multiply this one out. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. Negative 3 times negative 3 is positive 9. Okay, so 4x squared minus 6x minus 6x again plus 9. Okay, we have like terms, right? 4x squared comes down. Negative 6x minus 6x is negative 12x. And then plus 9 comes down because, again, that one is a constant term and it's the only constant term up there. Okay, so the distributive property helps, right? It helps us rewrite these multiplication problems, right? These expressions written as factors into terms. Okay, here's another one, or another couple. 3x minus 2 raised to the third power. Okay, so this one's going to be a little more painful. 3x minus 2 times 3x minus 2 times 3x minus 2. Okay, we're going to multiply all that out, but you can't really do it all at once. Okay, be careful to avoid the mistake of raising this to the third power and raising this to the third power, right? You can't do that, unfortunately, right? It's more complicated. The whole thing is being raised to the third power. So what we're going to do is start off by just multiplying these two together, see what we get, and we'll multiply that times this one. Okay, so 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Negative 2 times 3x is negative 6x. Negative 2 times negative 2 is positive 4. Okay, all of that was the first two parentheses, and this 3x minus 2, I'm just going to bring that down because I didn't do anything with it yet. Before I go any further, I should probably combine my like terms here. Negative 6x minus 6x is negative 12x. So this is going to be rewritten as 9x squared minus 12x plus 4 times 3x minus 2. Okay, now we are going to, again, do the distributive property. We have three terms here that we're going to multiply times the two terms here. Okay, well, 9x squared times 3x would be 27x to the third power. 9x squared times negative 2 is negative 18x squared. Okay, now the negative 12x. Negative 12x times 3x is negative 36x squared. Negative 12x times negative 2 is a positive 24x. And then finally, 4 times 3x is 12x. And 4 times negative 2 is negative 8. Okay, so I have these 6 terms now that I need to see if I can combine any of them. Okay, well, 27x to the third power, it's the only third power up there, so I will just go ahead and bring it down. Negative 18x squared and negative 36x squared. Okay, we have two sets of x squareds, so negative 18 minus 36 is negative 44. So we have negative 44x squared. Okay, we have 24x plus 12x. That's going to be 36x, and this is definitely 54, not 44. And then bring down my constant term minus 8. So there we go. We have 27x cubed minus 54x squared plus 36x minus 8. Okay, great. What about x to the 5th power raised to the power of 6? Okay, now we are taking a variable with an exponent and raising it to another exponent. So let's explore what happens there. This means x to the 5th power times 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 x to the 5th power. Okay, we know that we add, right? We add when we have the same variable with exponents. So that'd be x to the 10th. Let me do it like this. This is going to be x to the 5 plus 5 is 10, plus 5 is 15, plus 5 is 20, plus 5 is 25, and it turns out we're actually missing one. This should be the 6th power, right? So there's 6 of these. So 25 plus 5 is 30. X to the 30, power of 30. Okay. We don't want to have to write that out every time, right? That's no fun. So what we're going to do is talk about our next law of exponents, which would be when you multiply exponents, or whenever you multiply a number or a variable that already has an exponent and you are raising it to another power, right? Let me restate that. You have a term already and it's raised to a power, and then you're raising it to a bigger power. You just multiply those exponents together. Okay, that's what I was trying to say and was just struggling a little bit. Okay, so multiply the exponents when raising a number or variable with an exponent to another power. Okay, again, that's what this is saying right here. You have x to the a raised to the power of b. You can just rewrite that as x to the whatever a times b comes out to be. So in our example a second ago, we had x to the 5th raised to the power of 6. And we found out that it was going to be 30. Okay, well, let's do it here. All right, show you how easy this is to do. X to the 5th power raised to the 6th power. 5 times 6 is 30. Right, that's all we have to do there. What about something like this, right, where we have two factors within the parentheses there being raised to a power? Okay, well in that case, all you have to do is recognize that each one is individually being raised to the 5th power. Okay, so 4 to the 5th power, that's 4 times 4 times 4 times 4 times 4, is 1024. And then 5 times 5 is 25. Okay, just do them separately. Okay, if you have multiple factors all being raised to a power, just do them separately. Okay, well, what about division? So let's move on to some division problems. 27x cubed divided by 9x. Now, we're typically not going to encounter this type of a notation when we're working through problems. So usually whenever you come across something that needs to be simplified, it looks like this. Okay, and so that's how we're going to look at it. Look at 27 over 9, and we're going to look at this separately. I guess let's expand it out. 27 times x times x times x over 9 times x. Okay, there we go. That's how we should look at it. Well, 27 divided by 9 is 3. And you'll notice x divided by x is 1, right? So this becomes 3 over 1. And this cancels out, in other words, giving you a 1 and a 1, right? So really your numerator is 3 times 1 times x times x. Well, 3 times 1 is 3, and x times x is x squared. And then this is all over 1, but don't actually put it over 1, right? Because 3 divided by 1 is just 3, so we don't need to write that over 1. Okay, so there we go. Let's do also this next one. 10x to the 8th over 15x to the 5th power. That's going to be 10 times x times x times x times x times x times x times x. Let's see, that's 7x is one more, 8 over 15 times x times x times x times x times x. Okay, I think I got the right number of x's up there. Okay, let's divide them, right? It's all written as factors. So 10 divided by 5, or 10 over 5 is 2 over 3. They're both divisible by 5, so I divided it out. And then these two divide out and give me some 1s. These two divide out and give me some 1s. Some 1s. Just going to keep going until I run out of x's. Okay, so now I have these three that's stuck on the top without being canceled out. Alright, so multiply all that together. 2 times 1 times 1 times 1 times 1 times 1 is going to be 2. X times x times x is x to the third power. On the bottom, I'm left with 3 times 1 times 1 times blah, 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 blah. It's 3. So I end up with 2x to the third power over 3. Another way you'll see this written out is 2/3 x to the third power, right? Where 2/3 is the number in front of x to the third power. Okay, that way is preferred in a lot of ways. Okay. We don't want to have to do it this way every time, so it would be convenient if we had another of those laws of exponents. Oh, look at that. We sure do, right? We have how would I say this? Subtract exponents when dividing variables. Okay, that's just a simple way to put it. If you have the same base, right, the same variable being raised to a power, doesn't matter what those are, if they're the same numbers or different numbers, you can simplify it, consolidate it by subtracting those exponents. Okay, so let's put that to work here. Again, I'll rewrite this, 27x to the third power over 9x. This is an understood first power. Let me write that in right there. First power. Okay, so 27 over 9 is 3. X to the 3 minus 1 is 2. Much quicker to do it that way. Okay, what about this one here? 10x to the 8th over 15x to the 5th. Okay, well, 10 over 5 is 2/3. Let me just write it like that, 2/3. And then 8 minus 5 is 3, so we end up with x to the third power. Okay, much quicker when we implement that rule. Okay, well, let's move on to some more like that. How about 2y to the 5th power divided by 7y to the 4th power? 2y to the 5th power over 7y to the 4th. Okay, well, 2/7 I can't really do anything with that, right? That's going to simplify to be just 2/7. And I'm going to subtract 5 minus 4, and I get 1. So that's going to be 2/7 y to the first power. Well, we're not going to put that little 1 up there. It's understood, so we don't put it. 2/7 y to the, 2/7 y. Okay, what about 7y to the 4th power over 2y to the 5th power? So I just flipped them around. 7 over 2 stays the same, and if I subtract them, 4 minus 5 is -1. Okay, that's a valid answer, but let's talk about what that means, right? So, let's write this out the long way, just so we can make a point. And I'm sure many of you already see what that is going to represent. Alright, so if I divided this out, those divide, give me 1s, those divide, give me 1s, gives me 1s, 1s. I'm left with 7 on the top and 2y on the bottom. Okay, these two are equivalent. They mean the same thing. Okay, if you have a negative exponent, that just means it belongs in the denominator. Okay, or it also means that if you have it in the denominator, it belongs in the numerator. Okay, so let's talk about that. Oh, look at that, another one of these exponent rules. So, a negative exponent means that the variable or number is in the wrong position. So, numerator or denominator. Okay, so here are the two examples of that. Okay, x raised to the negative a power is the same thing as 1 over x to the positive a power, right? Notice there's no fraction written right here, but again, it's understood that there's a 1, right? There's a 1 in the front and then there's a 1 in the denominator. Well, you could look at it as taking this and moving it down here, right? And making it positive. That's exactly what's going on. That negative just means it goes in the bottom. Same thing is true if it's in the bottom, then you can bring it up to the top. So this is 1x to the a over 1. Okay, again, we clean all those extra 1s out to make it look a little cleaner. So these are saying the same thing. These two things are saying the same thing, just one's more abstract than the other. Okay, so let's see. Here's some examples of that. So 5n to the negative 7th power over 9. If I wanted to rewrite that, I'm going to recognize that n has a negative 7. Notice that the 5 does not have an exponent, so don't think that that negative 7 has anything to do with that 5. Okay, the negative 7 is on the n, so that means n is in the wrong position. I need to put it in the denominator with the 9. So that's how that would simplify. 9 n to the 7th power is in the denominator now. What about this one right here? Notice n has a negative 7, so that means the n to the 7th power is in the wrong position. I need to bring it up. So this becomes 5n to the 7th over 9. Okay, the negative exponent just means it's in the wrong position. Okay, so now let's do some more complicated problems as we approach the end of this section. 3y to the 8th power times 4y to the negative 2nd power over 6y to the 10th power. Okay, I am going to just pick this one apart and say, I'm going to do the top first, right? Let's do the top first. Ignore the bottom. 3 times 4 is 12. Y to the, add the exponents together. Now, you're adding a negative, so you're really going to subtract it, but 8 plus negative 2 is going to be 6. Now the denominator, 6y to the 10th power. Okay, 12 over 6 is going to be 2. Subtract your exponents. 6 minus 10 is negative 4. So this becomes y to the negative 4th power. Okay, another way to write the same problem out is 2 over y to the 4th power, right? I can bring the y to the negative 4th power down. Okay, what about this one here? 5t squared over 6 times 2 over 3t to the 5th power. Okay, well in this one, let's just multiply the tops together. 5 times 2 is 10, so it's going to be 10t squared over 6 times 3t to the 5th power. 6 times 3 is 18, t to the 5th power. Okay, let's subtract those exponents. 2 minus 5 is going to, 2 minus 5 is going to be a negative 3. So let me do 10 over 18 first. Those are both divisible by 2, so that's 5/9. T to the negative 3rd power. 2 minus 5 is negative 3. Or I could rewrite this as 5 over 9t to the 3rd power. Okay, I write it this way if I want to have a positive exponent. I write it this way if I'm content with negative exponents. But either way, both are fine. Okay, what about these two right here? So we have negative 2x to the 12th power times 5x to the negative 7th power over 15x to the 4th power. Okay, let's do the top first. Negative 2 times 5 is negative 10. X to the 12 plus negative 7, be careful with your signs. 12 plus negative 7, that's 12 minus 7, that's 5. Okay, and then that gives me 15x to the 4th on the bottom. Okay, now let's simplify that. Negative 10 over 15 is negative 2/3. And then subtract my exponents. 5 minus 4 is 1, so x to the 1st power. No negative exponents appeared there. Okay, what about this one? 10x to the 14th times negative 3x to the negative 9th over 2x to the 5th. Okay, let's do the top first. 10 times negative 3 is negative 30. X to the 14 plus negative 9. Again, be careful with your signs. 14 plus negative 9, that's 14 minus 9, which is 5. Over 2x to the 5th. Okay, now let's divide it. Negative 30 divided by 2 is going to be negative 15. X to the 5 minus 5 is 0. X to the 0 power. Okay, stop right there. What does that mean? Okay, x to the 0 power. Well, if we did this the other way, right, this and this should divide each other out and give you 1, right? 1 and 1. So we should have just gotten negative 15, but instead we got negative 15 x to the 0 power. So what does that mean? Well, x to the 0 power is just saying that you have no x's. Okay, 0 x's are present. Therefore, negative 15 is your answer. Okay, that's kind of what it's saying. Let's go into the last part here. The last of the laws of exponents that we're going to go over today. A number or a variable with an exponent of 0 simplifies to 1. Anything raised to the 0 power will simplify to 1. Okay, so what we're going to do here is try that out. 5 times x to the third power over 19 times 7 over 4x to the third power. Okay, multiply the numerators together. 7 times 5 is going to be 35 x to the third power. 19 times 4 is going to be 76 x to the third power there. Okay, 35 and 76 cannot reduce that, surprisingly. So I'm going to bring that down as it is. And x to the third over x to the third would give me x to the 0 if I subtracted the exponents together. But keep in mind, anything to the 0 power is 1. So this is really 35 over 76 times 1, which you know is just 35 over 76. Right? Okay, that's one way to look at it. The other way to look at it is x to the third over x to the third are going to cancel each other out. They're going to divide out and leave you with 35 over 76. So either way you look at it, that rule still holds. Right? You still can subtract the exponents, get 0, and still be able to find your way to the same answer as if you canceled them out directly. Okay? This is an easier one. 4z to the third power times 2z to the negative third power. Okay, well, 4 times 2 is 8. If you added those exponents together, you would get z to the 0 power, but you know that z to the 0 power is just 1. 8 times 1 is 8. Okay, or again, you have no x's, so you could jump straight to that and say, or you have no z's, so therefore you can say it's just 8 without any z's. Okay, anyway, so that was a rather long section, but that is multiplication and a little bit of division with